Today's video is on section 4.1, Antiderivatives and Indefinite Integration. Your homework will be out of section 4.1, 1 through 41 odd. Well, we're ready for the next big topic in calculus. The first big topic besides limits was taking derivatives. Now we're going to take the antiderivative, or it could also be called the indefinite integration, and this is the inverse of differentiation. In other words, we're going to go backwards. We're going to switch out our x's and y's. Therefore, differentiation is the inverse of antiderivatives. So let's begin with our general rule for integration, for indefinite integration. So this here is called your integrand. So I'm going to be doing indefinite integration on x to some power with respect to x. And so take a look at what we do in order to answer this. Is that when you take the derivative of this, usually you decrease this by 1. Now, since we're going backwards, we're going to increase it by 1 and divide by whatever our new exponent is, plus c, plus the constant of integration. Remember, we had talked about how we can't go back and exactly draw our original f function because of the vertical shifts. So when we go backwards and we're trying to find our original function, we don't know about that vertical shift, but we still have to put that in there. And you'll see that play out here again today. So I'm just going to write some general ways that you might see this. For example, the indefinite integration of the first derivative, right? First derivative with respect to x equals the original function plus c. That's taking integration. That's going back to the original. So I'm at the first derivative. I'm going to integrate it and go back to the original, plus your constant of integration. Why? Because this is indefinite. There's no upper and lower bounds on this. And you'll see that over the next couple of days. But I don't necessarily have to write it like this. I could just write some function. You just have to know it is the first derivative. And when you integrate it, you're going to go back to the original function. So f of x is a lowercase, and they could put a capital F of x. Again, it's just ways of writing it. There's the given function, and this is your antiderivative. And this one here shows you the circular argument. That here, this is what we're learning here today, that when you integrate this, you're going to go, like this is like the first derivative, you're going to go back to the original. So this would be back to the original. Now if I go and I take the derivative, you're going to go back to this function, which is the first derivative. In fact, maybe let me write it like this. Right, so I'm going to take the first derivative, and I'm going to do indefinite integration. In doing that, I'm going to go back to f of x. But when I take the derivative of f of x, I get the first derivative. That's better. Instead of using this notation, I use this notation. Helps you understand this. So this is the circular argument. Again, I'm just giving you some generals. We're going to work them some specifics here in a moment. I'm going to go and look at some more examples. So I'm going to show you some examples. This is the first derivative, and when I integrate it, going back to the original. Now, I didn't show the integrands here, and they're with respect to dx. I'm sorry, with respect to x. I'm just showing you that function in there. So if I have 2x, again, what do? I increase this by 1. That would be a 2, and then I divide by 2, so I get x squared plus my constant of integration. So what if I have 3x squared? That's my first derivative. I'm going to go ahead and do my indefinite integral. What am I going to get? Well, I write my 3, x squared. I'm going to raise that to 3 and divide by 3, so the 3's canceled. I get x cubed plus c, my constant of integration, because I don't know my vertical shift. What if my first derivative, I'm going to take the indefinite integral of 1. So that's really like x to the 0. So 0 is going to increase by 1, and you're going to divide by 1. In other words, it's just x plus c. What if my first derivative was x? I'm going to go ahead and do the indefinite integral. That means I go ahead and I raise this to 2, and then I divide by 2. So it's 1/2 x squared plus, again, my constant of integration, because it's an indefinite integral. 1/2 times the square root of x. Well, let's rewrite this. There. Now I'm going to go ahead and I'm going to integrate it with respect to x. In doing so, I'm going to still just copy the 1/2, write the x, I'm going to increase it by 1, and divide by this new one. That cancels out x to the 1/2 plus my constant of integration. Let me go ahead and give you some trig functions also. So if this is the first derivative, when I integrate it, we'll go back to sine of x plus c. If this is my first derivative, sine of x, and I integrate it or go back to the original, is negative cosine of x plus my constant of integration. Secant x times tangent x, if I integrate that, that'll be secant x plus my constant of integration. So let's play with this a little bit. Let's see why there's a constant of integration. So let's say my first derivative is 3. And when I take the antiderivative, go back to the original, right? Go back to the original. Then that's really x to the 0 power. So I'm going to increase it by 1, divide by 1. And it could be plus 4. Because I can do a check here. In fact, let me check. Let's go ahead and take the derivative of this. Take the derivative, it's just 3, right? So it could be 4. Or it could be, when I take the antiderivative of this, it could be 3x plus 1/5. Well, let me check. Let me go ahead and take the derivative of this. The derivative of this would be 3. Because that's just a constant, so it goes to 0 when I take the derivative. So it could be 1/5. It could even be a negative square root of 2. Let me check. When I take the first derivative, that would just be 3. So what it is I don't know what my vertical shift is. Again, let me check, because maybe it is negative 2/3. But when I take the first derivative, so what we must do when we do indefinite integrals, we must put this constant of integration. We do not know what that vertical shift is. You must do that. In the AP calculus test, they'll give you 1 point for writing plus c. Or in other words, you will lose 1. So that's an easy point. Make sure you do that. Let's do some more. So this is another way to write first derivative, correct? dy over dx equals x. That's with respect to x. Now let me show you how we're going to go ahead and do this integration. So I'm going to leave my dy here. I'm going to multiply both sides by dx. So this is with respect to y, this is with respect to x. And so just to give you some terminology, this is the integral sign, and this here inside is the integrand. So I'm going to take, and I'm going to differentiate, I'm going to integrate both sides. So my function in front here, it's just a 1. This one in front of this dx is an x. This is with respect to y, that's with respect to x. Let me go ahead and continue working out this problem. So when I go ahead and do the indefinite integral here, that's just going to be y. This one here is I'm going to write x, that's 1. Now I'm going to put 2 divided by 2, in other words, 1/2, plus my constant of integration. I am done. Let's do another example. Let's say I write my first derivative like this. Oh, I'm sorry. I want to do my check. want to do my check. I'm going to go ahead and take the first derivative of this and see if I go back to x. So I'm going to take to check, because in some of your homework you're going to check. Once I get y, the original, I'm going to go ahead and take the derivative to see if I get back to this, because y prime is the same thing as dy dx. So let's see, write down my 1/2, bring down my 2. I'm going to go ahead and decrease that power, and then that's just some constant number like 3. So I take the derivative, that's just 0. Y prime, that's x. It is confirmed that this is correct. Now we can try another problem. Maybe I'll start out and give it to you this way, where I've already done the indefinite integral of the left-hand side. Now I just need to do the right-hand side. So what I can do is I can take out the constant 3. Now I'm going to go ahead and do my indefinite integral. So I'm going to increase that by 1, divide by it, and my constant of integration. Clean that up a little bit. Now I'm going to go ahead and I'm going to do my check. I am going to take the first derivative and see if I get it back 3x. So 3/2, bring down my 2, x to the first power, and that's just 0. That cancels, and I get my original function 3x back. Next. Let's go ahead and do the indefinite integral of the right-hand side. First thing I'm going to do is I'm going to rewrite it. Now I'm going to go ahead and continue. I'm going to increase that by 1 and divide by that plus my constant of integration. Let's do another one. So we don't know how to handle when it's multiplication yet. So what we're going to do is we're going to go ahead and multiply that through. And then we're allowed to break it up and integrate each piece on its own. I'm going to go ahead and do that. So I'm going to increase this by 1 and divide by that. Plus, write down my 3, take my 1, increase it by 1, divide by that, plus my constant of integration. So that equals 1/4 x to the 4th plus 3/2 x to the second power plus c. I think I definitely want to check this one out. So I'm going to take the first derivative of this. I leave my 1/4, bring down my 4, reduce it. Write down my 3/2, bring down my 2, reduce it. And then when I take the derivative of any constant number, it's just 0. Let's clean this up. And there is my original function. I could go ahead and factor out an x and go back to the absolute original. I have one more problem I would like to do as soon as I find a blank sheet of paper. This one will have some trig in it. So this is with respect to t. I can go ahead and break this one up also. And each one gets its own dt to show what it's with respect to. I'm going to go ahead and do my indefinite integral. So I'm going to write down my t, take my exponent 2, increase it by 1, and divide by that. Minus. I'm going to go ahead and take the indefinite integral of sine of x, and that's going to be negative cosine, t, be negative cosine of t, plus my constant of integration. Go ahead and clean this up. Thank you.